Every electrical device we have in our house uses electrical potential energy, and it gets energy by charges moving from a higher potential energy to a lower potential energy. So think about an electric outlet in your house. Looks something like this. At least in America, there's plugs like this, and there's two sides, a left and a right. I'll draw a larger one here. There's two little slots here that you stick a plug into, and there's another one. But when you plug in, say you plug in your lamp, you've got your cord, looks something like this, and there's two prongs coming out of there, and they plug into those holes, and there's actually two wires down inside this cord. One's running to one prong and one to the other, and they're insulated, they don't touch, and they're not exposed to the outside. And so when you plug something in, say you plug in a lamp, there's one wire running from one side and one running to the other, even though they're both wrapped up in the same cord, and they run over here to the lamp, and you have a light bulb inside the lamp, and the electricity runs up here and goes through the light bulb, and the lamp glows. And what happens is electrons are flowing out of one side. They're flowing along one wire through the bulb and then flowing back in the other direction. And the direction actually alternates, but we'll talk about alternating current later. But what happens is the electrons on one side of this outlet are at a higher potential energy than they are on the other. And they flow from a point of higher energy to a point of lower energy. And the reason they have more potential energy over here on one side is because the power company provides power to your house that way. The electric outlet has different electrical potential energy on one side than the other, and the electrons naturally flow from one to the other. And this is just like a mass naturally falling down. Water, for example, naturally runs downhill. It naturally goes from a place of higher gravitational potential energy, and it flows down to a place of lower gravitational potential energy. Or if you hold something and drop it, it falls down every time. It never falls up or to the side. Things fall to a point of lower potential energy. And these electrons do the same thing. When you provide a path, when you plug in the lamp, you are providing a path for the electrons to flow, and they flow from the point of higher potential energy through the lamp to the point of lower potential energy. And in the process, they lose potential energy. And where does that energy go? Well, in this case, it's converted to light in the lamp. If you have a heater there, the potential energy is converted to heat. If you have an electric motor there, the potential energy would be converted into motion, into kinetic energy. So every electrical device that you have is making use of charge falling from a point of higher potential energy to a point of lower potential energy. And that idea of two different points being points of different electrical potential, a charge at one point having a different potential energy than it has when it gets to the other point, that's one of the key concepts behind voltage, which we will get to next.